Welcome to Tech Talk. My name is Clayton Forbes. I'm one of the operations managers here at National Technical Systems, aka NTS. Today we're going to be covering MIL-STD-810H. P1 and P5 are pretty much similar to each other. There's the level changes based on the platform. Back in earlier MIL standards, you used to run a terminal sawtooth, 40 Gs, 11 milliseconds, or 20 Gs, 11 milliseconds, whatever shock pulsar is. But as technology's matured, the documents matured, and instead of running the sawtooth test, most customers, including NTS, opts to run the shock response spectrum test. Now, the shock response spectrum is just what it is. It's a response to a shock input. We'll design a drive wave, input into the shaker, hit the spectrum. It's done at 1/12th octave intervals, but there is some limitations on the time history. The time history is the drive wave we put into the shaker to produce this shock pulse, this shock response. There's a big TE and there's a little TE, which is the duration of the test. When you read into the document will say, there's not enough time. If you have to make the curve all the way down to 5 hertz, there's not enough time in the allotted window inside MIL-STD-810G to hit the whole curve. So if you've done some research and you don't have any resonances in the low frequency, we can miss that response spectrum, the shock response spectrum, the RRS, on the low frequencies. Then we can hold TE pretty well. But if no research is being done, you need to hit the curve across the whole frequency range. We will exceed TE, most labs will, but there is some mathematics in there to calculate so you don't exceed the TE by too much of a value. So we do prefer the shock method, the SRS method over the shock method, but if you still prefer to do the 20G sawtooth or the 40G sawtooth, depending on the vehicle, that's fine as well. So that's P1 and P5 sort of combined together. Again, P1 will run right after we run P1 of vibration, or if we're doing whatever category of vibration. Crash safety, a little bit more risky to interlock it. Some clients will go ahead and do it if they have some high confidence in their unit. They will just do vibe, shock, and then rotate. Save you some time, save you some money. But if you don't have that much confidence, interlock shine and shock together, or random and shock together, and then go back through the axes and do it again. Now the P1 and P5 shock is usually, it used to be unidirectional, now it's kind of bidirectional. So we can usually hit the positive and the negative at the same time. If you hit the positive and negative at the same time, you just have to run the SRS max analysis, hit it 1 time or 3 times, and then go ahead and rotate it. If you miss one of those directions, obviously you can spin the unit 180 degrees to catch the other shock axis, as opposed to vibration, which happens in both axes all the time. And catch that other axis, or we can reverse the polarity of the pulse. But that's usually not an issue. Usually both primary positive and primary negative we can hit at the same time. Very tight tolerances on them. So that's P1 and P5. P4, transient drop. Exactly sounds like it is. MIL-STD-810H, they added some more drops to it. There's a logistical drop, which is the standard drop we're all used to if you're familiar with 810. You take the box, you put the unit inside the box, you drop it 26 times depending on the weight, from whatever height it is. 26 times includes every edge, every corner, and every flat. Again, depending on the weight, we'll determine what we drop it from. One interesting in the document that some people don't take advantage of is, a box isn't really designed to take these 26 shocks all at one time. I mean, obviously, if it does, you need a new shipping or a new carrier, right? But in general, you can use up to 5 different units if you want to get through this test. I know logistically or financially that could be a problem, but it does allow you to change out units during this 26 drop for logistic. And then they added in what's called tactical drop and severe tactical drops. So depending on the vehicle and how you're going to be dropped, air dropped or whatever, the drop height can change, but the test format's pretty much the same. You know, you're going to use a quick release hook, raise it to whatever height, 48 inches for the logistical drop for the lighter boxes, and just let it fall and hit the floor. If it rolls, it rolls. Same with the severe, and that's basically the drop test. Make sure the unit works before, package it, drop it, switch it out if you need to switch it out. At the end, look for damage and make sure it still operates. Make sure logistically gets there. So that's P4, P5. So P6. P6 is what we call a bench handling drop. It's more of the unit's being worked on, bench handling. So you open apart the unit, you take the cover off, you go to slide your hand out, and inevitably the unit falls a little bit, right? Because the clearance between the dust. So basically that's what we're simulating. We'll take the unit, obviously non-operational usually, raise one edge 45 degrees or 4 inches, use the other edge as a pivot, and just let it free fall to 4 inches or 45 degrees. We'll do that on the front bottom face, the left bottom, right bottom, back bottom, and then any other way that the unit can be set. If you can flip the unit upside down to work on it, then we'll flip it upside down. Usually, front and back, on a 1U or 2U unit doesn't come into play because of the connectors or whatever it may be, the stability. So just, use some in judgment. Again, it's test sequence. Depends on your life cycle, but like I mentioned, vibe and shock is done usually not late, but maybe mid-cycle. After you get through all your temperature testing, maybe do some water testing. But vibe can have the tendency to beat up some of these gaskets. So if you're in pre-test, maybe you want to beat the unit up a little bit in vibration, and then do your immersion test, your rain test. Method 507, which we haven't talked about yet, your humidity test. Give you a little bit more confidence that the sequence doesn't matter. But obviously, if you're qual, you want to get through it. But so just follow your life cycle or logistically what you need to do. So that's basically method 514 and 516 of MIL-STD-810H. Thanks for joining.